Hello, welcome to this webinar on reducing dairy sector energy costs. I'm David Eyre, GM Research and Innovation at New South Wales Farmers. Today we're going to go through the key opportunities and talk about where more resources can be found as well. Energy is a key business risk for dairy. Dairy, as you know, is an energy-intensive business and energy costs are steadily rising across all forms of energy. Research has shown 40% of Australian dairy farms can save between $2,000 to $10,000 per annum. That's research done by Dairy Australia and other bodies. Our experience at New South Wales Farmers doing audits on dairy farms supports this finding. We find that while most farmers have taken some action to reduce energy costs, they're also missing some pretty big opportunities for savings. It's best to take a systematic approach to managing energy costs, and we always recommend that farmers start with an energy audit. This is critical to understanding your energy use profile. You need to hire a professional to do an energy audit. The next step is time of use management and smart purchasing. This is about really understanding the times of day at which you're using your equipment, and if you can, moving that time of use onto a lower tariff, for example, if you're using electricity. Also important is really looking at your contracts and renegotiating them if possible so that you get the best possible deal. Having gone through those measures, you can start looking at energy efficiency. That's making sure your equipment is set up in an optimal way and possibly purchasing some new equipment like variable speed drives for your pumps. Finally, and we recommend finally, you look at renewable energy options. So although there are some very attractive options in the area of renewable energy, we think it's important to get your house in order first. And starting with an energy audit, you'll have the data that allows you to make smart decisions about renewable energy. What's an energy audit? Well, it's finding out where your energy usage is going, and it allows you to benchmark performance against average for your sector. It's important to do those numbers, and it's helpful to have a professional do it for you to uncover the energy being used and the cost and potentially the wastage. On the basis of an audit, you can identify some cost-effective changes. This is a breakdown of the energy costs of an average dairy in the Moree region. You can see that milk cooling is probably the largest single cost, followed by hot water, milk harvesting, water supply, cleaning and effluent, preparing feed, and then finally lighting and other in the building costs. This pie chart gives you another view of that. Hot water, LPG or electric. Lighting, as you can see, is very small up the top there. Pumps and motors are a big cost, and refrigeration, of course, is a very large cost. Here's the data for one of our members' farms, Bioenergy Dairy. There's a case study about Bioenergy on the our Ag Innovators website. Looking at this on the vertical bar is the percentage of total energy usage. On the left of the histogram is the diesel being used, in the middle is electricity being used, and finally on the right is petrol for other vehicles. Breaking down the diesel, we have tractors, but the biggest cost there is pumps and drives. This is an irrigated dairy, so water pumping is a very large cost. In a homestead, up the top there you can see we've got a bit of lighting and other homestead costs. Refrigeration is a large cost. Hot water is bigger than refrigeration, and then pumps and drives in the dairy buildings themselves are another 18%. These are big electrically powered devices. And finally we have petrol for cars and so on. And an auditor, of course, has got this data together for the farmer. So it's really important to understand that you've got a lot of different kinds of energy on a typical dairy farm. Unleaded fuel, diesel, electricity, LPG and diesel for pumping. which might be a different grade of diesel. On the basis of this data, you can start to benchmark and to compare it to milk production. The way the auditor will do this for you is to add up a year of energy usage for the dairy shed, the total kilowatts of electricity, total litres of LPG or diesel, and then remove other usage if possible, house usage, for example, if on the same electricity bill. We'd recommend generally that you split your bills. And then convert that data to the same format. 1 litre of LPG equals 7.2 kilowatt hours. 1 litre of diesel equals 10.7 kilowatt hours. In other words, converting it to an electricity metric. And then to divide the total kilowatts for the year by total milk production volume. That will give you a sense of the productivity of your energy usage. Here's an example from one of our members' farms, one of our case studies. Total electricity usage was 90,500 kilowatt hours. Subtracted the house usage. The LPG usage was 4,000 litres. That's ended up with 28,800 kilowatt hours. Total energy for the property was 107,300 kilowatt hours. Divide that by milk production and we get 33.5 kilowatt hours per kilolitre of milk. Now the average for the Moree dairy region is 51 kilowatt hours per 1,000 litres of milk, with an energy cost of $10 per 1,000 litres. An example property, the data we're showing you here, it was actually quite a bit better than that. It was 33 kilowatt hours and an energy cost of kilolitre of milk of $7. Now, who knows where you would sit if you do this kind of comparison. You might be below, you might be above average, but without an audit, you won't really know. So step 2, this is back to smart purchasing and managing time of use. This example is about electricity. As I'm sure you know from your bill, you're going to have the opportunity to peak or shoulder off peak. Now have a look at where you're using your power, and if possible, move that power usage to a lower tariff rate. And that's not always possible with dairy, we know, but it's sometimes quite surprising what can be achieved. And of course, when you start putting renewables into the mix, it's possible to reduce peak usage with, let's say, solar during the day. It's very important to look at your service charges, and in some cases it might not be necessary to be connected to the grid because you're going to pay connection costs even if you're not using the power. It's also very important to negotiate with your supplier. Talking to your energy retailer about the most cost-effective contract for you but also for them can result in quite significant savings. There are also discounts being offered, and it's a competitive market and the retailers try to churn, and if you just go to someone different, they might offer you a better deal just to get you onto their books. Step 3 is energy efficiency. This means looking at your equipment to see where you can save power, either at the input side or through wastage, reducing wastage. VSD, variable speed drives on vacuum pumps, are a very effective way of reducing the power required. Heat recovery units can improve the efficiency of refrigeration. Larger plate coolers, insulating your pipes is a bread and butter measure. The variable speed drives on evaporator and condenser motors, and of course LEDs and other efficient lighting equipment. Although lighting is generally a pretty small component of total energy, it's a very easy thing to fix, and there's usually government incentives for switching out your lighting. So step 4 is probably the most interesting step for everyone, and it's renewable energy. Solar hot water is an easy thing to do. Now, a lot of hot water is used in dairy, and putting some solar heating panels above your tanks can really save a lot of money, and many farmers already do that. Solar PV is more complex, and I'll get onto that in a moment. And then finally, there's bioenergy. Bioenergy, biogas is really quite attractive for large, intensive animal firms you probably need to be fairly large to make it worthwhile. It's about capturing methane from animal waste. You can burn the gas to create electricity. You can also register a carbon scheme to get credits for methane destruction. It's suitable for bigger dairies because there's significant investment required to establish a methane capture system. It also entails changes to your operational model around the management of waste and so on, and might involve some new infrastructure in that area. But there are waste management co-benefits in terms of environmental impacts of effluent and also smell. Dairy Australia have done some really good work in this space, and you can either go to their website or look at Ag Innovators to find that stuff. There are many options for solar energy, and it's quite important to understand the technology in the context of your farm and what your actual needs are. But once again, an audit will help you to do that. One option is grid connected. That's where your solar panels are connected to the grid and you sell the excess power into the network. The benefits of that kind of depend on the price that are being offered for energy at the time, and that can vary. The freestanding system is when you're planning to use all of the solar energy on the farm itself and not sell any to the grid. Hybrid systems are a very attractive option if you're running an irrigated dairy and it's using diesel and diesel genset to supplement the solar at the times of peak load. And then finally there's battery storage, which really can help you get better value out of the solar array by allowing you to shift the energy out of peak sunshine hours. The factors you need to consider, whether you're grid connected for a start, what is your daily and seasonal load profile, in other words, where the peaks of your energy usage, is battery storage cost effective, and what is the best system size if you're going to be spending money on solar infrastructure or any other renewable energy infrastructure for that matter. A quick look at grid connected. It's important to, if you're going to grid connect, to get your system size right. If you get the size right, there could be a payback period of between 3 and 6 years, which is quite attractive. The pricing trends, in other words, what you'll be paid for your electricity, can be accessed online. There's a URL there. Solar Choice have got a pretty good tool for that, which you can Google rather than copying that down. And you can see that the dollar per kilowatt paid is, varies considerably on those charts at the bottom. Here's some examples to show you how important system size can be in your payback and the return you're going to get on the system. This example, you can see that the smaller system here to the left is achieving a better payback. Payback's 3.7 years. The red in these graphs is the proportion of power exported from the system. Now, because relatively low prices are paid for power, you don't really get that great a return on the power that's exported. The system on the far right is the largest one. There's more electricity being exported, but the payback period is considerably longer, 6 years. So our recommendation is if you're going to go down this route, you really need in the first place a pretty damn good audit done, but you also need to engage a competent solar engineer to assess what exactly the optimal system for you is. Water pumping, as I said before, is a critical cost for irrigated dairy. Solar, either as a freestanding system or a hybrid system, and a hybrid grid-connected system is really worth evaluating. Your load is typically going to be seasonal. In other words, high voltage is only required in summer when you're pumping for the most. You really need to do analysis to find the ideal system size. A diesel genset combined with a moderately sized solar array can probably provide the best payback. In other words, you'll use solar only during the off-season period and then you'll top it up with diesel to meet the summer peak. That means you don't have to have a whole lot of solar infrastructure sitting around underutilised for the majority of the year. In other words, you only need, your peak load is likely to be 3 or 4 months. Here's an example of a hybrid diesel solar installation in Moree, now one of our members that we've analysed. They're pumping 890 megalitres per year, and it's 24/7 operation during peak season, both diesel and solar, but solar only operation during the off season where there's much lower pumping volume required. This is the array. This is how it all works in a sort of generic sense. You have a three-phase genset, you have a solar array up the top here, electric bore pump motor, optional battery storage, digital controller, all sort of controlled internet wise, so you control it from a farmhouse or remotely. Pretty sophisticated system. And this is really the future of energy and agriculture, this sort of thing. Here's some charts showing you really what the results are. The green here is for solar, and the red on either side is when the system's using diesel to meet the energy load. This is an example single day result when there's full sunshine available. And you can see not too much diesel being used, and the diesel cost per megalitre, total megalitre pumped, is $8.39. This is another day, January 4th, 2016, when it was actually cloudy. And you can see much more diesel is required because there's less energy coming from the sun. But because it's a hybrid system, the pumps are still running, you're still getting the power you need. You can learn more about this sort of thing on the New South Wales Farmers Ag Innovators website, or by ringing member services. We can send these documents out to you. We've got a pretty large manual on solar pumping and agriculture, and there's some brochures as well. Okay. Batteries. Batteries are very much in the news at the moment, as I'm sure you're aware, and Tesla's probably the most famous of the firms manufacturing batteries. They're big, professional, industrial scale batteries. You can pretty well build a battery to store any amount of energy. The challenge really is cost. We've got a pretty useful battery financial calculator on the Ag Innovators website, which a lot of people use just to get a feel for whether batteries are cost effective. The point of having a battery is that it allows you to shift the solar energy to a time of day when it might be more useful to you. Now you store the power so you can use it when it's needed. It can significantly reduce the need for grid supplied power. So this chart here, this the yellow is the middle of the day there, and you can see there's a peak of solar power coming in from the sun. And the blue curve here is the power demand curve during the day. What we're showing here simply is that the solar generation peak can be shifted using batteries to use it at night time, for example. In this example, if you wanted to irrigate it at night. Equally, that could be shifted to the morning, the following morning when you're milking. The thing with batteries is maybe a year or so ago they definitely weren't cost effective, but the price of them is falling quite rapidly, driven by the car industry. And it's becoming more cost effective almost it seems every month to look at batteries. So we always say watch this space and seriously consider installing batteries, particularly if you already have a solar array. I mentioned aginnovators.org.au. This is the New South Wales Farmers Innovation Portal. We've got a project. You can see up the top there's a project section in the website. If you click on that, you'll get all the projects that New South Wales Farmers is doing and Ag Innovators is doing. There's a project there about reducing energy costs in dairy, where you can find a lot of information about the various aspects of energy productivity on a dairy farm. And of course, you can see up the top right there the battery storage financial calculator. If you're going down a solar route, it's absolutely essential to do your diligence on the installers and their warranties. On the right, you can see this pyramid here. The top tier manufacturers produce really much better equipment. It's likely to last longer. They're investing more money in R&D. It's going to perform better. So whoever you use, we do recommend that you do use high quality gear, even though it may cost a little bit more. The inverter is particularly important. You can get away with cheaper panels, but you really need the inverter and any digital control system to be top-notch. There are accreditation models, so absolutely go for something that's Clean Energy Council accredited. You need at least a 5 to 10 year installation warranty. A panel warranty should be at least 20 years. It's really important to use an experienced and reputable installer who's active in your region Some of our members are very remote, and they've had someone install a system who then maybe lives in Sydney, and then their local electrician has to fix it, and that doesn't usually work out terribly well. Get quotes from multiple installers too. If you're going to go down this route, it's really worth putting a bit of effort into the planning phase. So where do you get the money for this? There are actually quite a lot of incentive programs out there depending on the scale of system that you want to operate, but there are low interest loans available from Clean Energy Finance Corporation. New South Wales Government operates a Farm Innovation Fund, and there's solar leasing as well. For example, someone will put a solar plant on your property and then kind of lease it back from you. Worth investigating this area. A little bit more about Ag Innovators. Encourage you to go there. It's generally a very good source of information about innovation in agriculture. And as I mentioned before, at the bottom here, here's an example of a landing page for energy costs in dairy. Finally, we're collaborating with CSIRO, Food Innovation Australia, and other bodies to explore cost-efficient production solutions in dairy. For example, milk dewatering on farm is an interesting area of technology that's evolving at the moment. Innovation in cold chain technology is a related area. Things like smart fencing and farm instrumentation can really help with the management of the herd, and taking time and cost out of the value chain on farm. That's it for me. Thank you very much for joining the webinar, and as I said, please do have a look at Ag Innovators for more information.